Alright, so in this video we're going to look at kind of a pretty challenging problem. It combines many different types of factoring that we've talked about, but it's all kind of in the same problem. So if you haven't already tried it, give this video a pause and see if you can see how far you can get with this, and then we'll take a look at it. So the reason obviously this is a harder problem is because most of the times when you solve a problem you're just focusing on one technique, okay? But in this case you can see all of these things that are listed here. Some or all of them are going to be used in this single problem. So the first thing is we have 6 terms, and so what we do when we have 4 or more terms is we use something called factor by grouping. So if you look at the first 3, we have these together. It looks like they all have an x to the 6th in common. So I'm going to pull out an x to the 6th from these first 3. And when you divide each of these by x to the 6th, x to the 8th divided by x to the 6th is x squared. 2x to the 7th divided by x to the 6th would be 2x to the 1st. And then lastly, x to the 6th divided by itself, that just equals 1. Okay, so if we're doing this correctly, then when we group this second half together, these last 3 terms, we should get the same exact thing. And you can almost see it's almost the same already, except all of these are negative. That's a negative, that's a negative, that's a negative. So the only factor that those have in common would be a negative 1. They're all negative. There's no number that goes into 1, 2, and 1, okay, because this is a 1x squared. The only number that goes into those 3 numbers is 1, and they don't have a power of x in common. X squared and 2x do, but the minus 1 at the end does not. So let's pull out a negative 1 from these, and if you divide each of these terms by negative 1, all that happens is they just switch signs. So that becomes a positive x squared, positive 2x, and then a positive 1. Alright, so this is good because now this is what we wanted. We wanted to have the same thing showing up in both parentheses, and it does. So let's do this. Let's pull that into its own parentheses. That's a common factor. That's something that they both have in common. They both have an x squared plus 2x plus 1. Okay, and then in the other parentheses we can pull x to the 6th minus x to the 1st. So you might say, well, why is that a hard problem? It looks like that was pretty easy. I mean, all we had to do is factor by grouping, but we're not done yet. We're actually not even close to being done because there's a lot more factoring that needs to be done here. So let's start with the easier one first. Let's start with x squared plus 2x plus 1. That's a little bit easier. So this one right here is something that we've factored before. We're looking for numbers that multiply to positive 1 and that add to positive 2. And the only things that do that would be 1 times 1 equals 1, and 1 plus 1 is 2. And then we need an x plus 1 and x plus 1. Alright, so at least we're done with that parentheses right there. Okay, we're not anywhere close to being done with this one though. X to the 6 minus 1. So the first thing is we've taken care of factor by grouping. We may have to do that again, but we're also being told that there's differences of squares here, and there's also sums or differences of cubes. And this right here is kind of both of those things, but this is important. It says always factor the difference of squares before we factor the difference of cubes. If we don't do that, the problem will be significantly harder. So let's treat this right here as a difference of squares. And you might say, well, that doesn't look like a difference of squares, but look at it carefully. This right here, x to the 6, you can ask yourself, what did you square to get x to the 6? So I'm just coming off here as a sidebar. What did you square to get x to the 6? And the answer is you squared x cubed, because you're supposed to take those exponents and multiply them together. So in this case we'd have x cubed times x cubed. That would get us to x to the 6th. And 1 is also a square. 1 is 1 times 1. And then to get the minus, like in a difference of squares, one of these has to be plus and one of them has to be minus. Alright, you might say, well, are we done? Are we done yet? No, or actually we still have to keep going. So these now, both of these, both x cubed plus 1 and x cubed minus 1, those are actually sums and differences of cubes. Okay, you might remember from an earlier section. So let's factor those. Okay, let's factor first the sum of cubes right here. So I'm going to put that in blue just to give us some space. It'll be right here. Alright, so you might remember the pattern for a sum of cubes. Let's fill in the signs first. Okay, the signs go same, so that's going to be plus, opposite, and the opposite of that plus is a minus, and the last one is always plus. Okay, then what goes here and here are the things that we cube. So we cubed, what do we cube to get x to the 3rd? We cubed x. And what do we cube to get the 1? We cubed a 1. And then the first term's exponents, the first term being the x right there, the first term's exponents count down starting at 2. And the reason we have to start at 2 is because this right here is x to the first. That's x to the second. If you multiply x to the first times x to the second, that's what you get. You get x to the third. So x to the second, x to the first. The last one is going to be x to the 0, which means we don't need to write it. Actually, I'm going to use a different color for this. So this is our 1 term right here. This goes 1 to the 0. 1 to the first. I don't really need to write 1 to the first. We'll write it, and then finally 1 to the second. Okay, now how can we simplify that? Well, let's just rewrite it as x plus 1 times x squared minus 1 times x is just x, and then 1 squared, of course, is 1. Okay, so that takes care of that first one. Okay, this one is almost the same. I'm going to write it down here, actually, because we can kind of write it out directly. It's really almost the same, except now it's the difference of cubes. So it goes same, opposite, and the last one is always plus, but everything else is the same. Instead of x plus 1, it's x minus 1. This is still x squared, this is still x, and that's still 1. And then finally we have this right here, which is x plus 1, and then times another x plus 1. So believe it or not, this whole thing right here, this entire thing that has, how many parentheses does it have? 1, 2, 3, 4, 5, 6 parentheses in it. That is the factored form of what we started with. And the advantage to having it in this form is if for some reason this was equal to some equation. It's not equal to anything now, but suppose that you were given this problem and it said this equals 0. Well, you could easily find what would make each of these parentheses 0. This one in the middle, you could use the quadratic formula. Okay, like for example, this one would be x equals negative 1. This one would be x equals positive 1. Here's another negative 1, and so on. So it's much easier to solve an equation when it's in factored form. But that was just a challenge to see how it looks if you had many different types of factorings in one. So hopefully that made sense.